Does this water look polluted to you? Although it may not seem like it, deep beneath the surface lays a dead zone, or water that doesn't contain enough oxygen to support living organisms. Dead zones are found in bodies of water throughout the world. Sometimes they occur naturally, but in recent decades, nutrient pollution has increasingly been fueling their formation. Dead zones form when too many nutrients from human activities enter coastal bodies of water. The nutrients come from sources such as fertilizer on lawns and farms, feedlots, sewage effluent, and the combustion of fossil fuels.
The reason why lots of nutrients are not good for our coastal waters is because the nutrients feed these microscopic plants that grow in the water, much like they feed your garden plants or trees. And when all these microscopic plants grow in large numbers because of the extra nutrients that we're adding to the system, they eventually die and sink into the deeper waters of our bays. And when those dead phytoplankton arrive in the bottom, there's lots of organisms that like to consume them to obtain their own food. And that process consumes oxygen. So the more nutrients we add and the more algae that are growing, the more consumption of oxygen we ultimately have in the bottom layer.
Dead zones can have dramatic consequences for aquatic ecosystems. Living organisms are rarely found in dead zones because they escape to find water with more oxygen. Organisms that are slow or attached to the bottom, like clams and worms, die because they can't escape. Sometimes fish kills can even occur when a school of fish gets caught in the dead zone. Throughout the world, an increasing number of water bodies are being affected by low oxygen conditions. Dead zones are also expanding in size and severity on a global scale. These trends result from changes people have been making to the land that drains into our coastal oceans and estuaries.
We're increasing on a global scale as well as a regional scale the amount of nutrients and organic matter that are entering into our coastal waters, and those pollutants are enriching the ecosystems, which is causing the increased consumption of oxygen.
Since the introduction of chemical fertilizers in the 1950s, dead zones have rapidly increased in size and number. In more recent decades, many coastal areas have been experiencing population booms, resulting in increased nutrient inputs from urban development. In addition, natural landscapes that can filter nutrients, such as forests and wetlands, have been lost to make way for housing and industrial development. Currently, scientists from many disciplines use a variety of techniques to study the causes and effects of dead zones. Chemists, physicists, biologists, and ecologists work to learn more about how natural and human factors contribute to dead zones and how ecosystems are affected. Their research involves conducting laboratory experiments as well as monitoring dead zones through observing buoys and field sampling. Scientists also use computer models to answer questions like how will dead zones change over time.
We can take information that we have that relates one variable, let's say how temperature controls the consumption by bacteria of organic matter and the decrease in oxygen concentration. We can take those relationships and we put them into equations, and the equations then are connected in a computer to make calculations which allow us to take that information and make broad estimates of conditions, let's say, in the whole bay, and how they change in time, and how they might change with changes in climate.
While dead zones continue to affect waters worldwide, scientists are continually gathering new information that managers can use to promote better water quality.